Good late night, people. How are you all doing? Welcome to my illustrious, very well known, prestigious channel in my studio, aka my kitchen. I'm making this video because I think I have a lot of useless information in my head, or maybe useful. And I'm going to be talking about, of course, tonight, cancer again. And, you know, I think some of the things that I understand about cancer and DNA and how cancer is a mutation of the cell's DNA. Basically, the cell has become immortal. It does not die. And it divides more cells that do not die, and thus repeat cycle. Cancer is basically, forgive my archaic method here, if I was some ultimate editor or computer science major, I'd be able to make something really nice and pretty for you guys, edited version. So I want to act like I have an artery here. Okay. Basically a pathway for blood. At the end of it, I got a kidney. Okay. So I'm not even going to comment on what that looks like, guys. Stay focused. Okay. So here's your artery. This is where the blood flows. Okay. I can draw little arrows. Blood flow. And over here, and if this reads backwards, that's because the camera flips everything. You have to get a special lens to make it where it doesn't flip the image. That's why whenever I did my last video on soy power and Kyle, my cup read backwards. But anyways, so if this is backwards, it says kidney on it. So here's the blood flow. Here's artery. And here's a kidney. Okay. Okay, and inside kidney is all these other veins and arteries that supply all the blood to the kidney. Okay, now, what is cancer? Real basic. The complex nature of medical terminology makes cancer seem very mysterious. How it kills people. And it's actually quite simple how it kills people. See, when you have cancer, here, what I'm going to do is now I'm going to infect this kidney with cancer. And I'm going to illustrate the infected kidney. Cancer cells are going to be in blue. Okay? And then I'm going to infect the surrounding artery wall. And then I'm also going to have cancer tumors popping up in all the surrounding blood supply. So, now, cancer. Here's blood flow, but then here's cancer right here in the blood flow. And then what happens as cancer grows and grows and grows and grows, pretty soon there's no blood flow. There's no flow of nutrients. There's no flow of essential living materials. No blood to the affected organ and also inside of the organ. The healthy cells are starved to death. It's why when you get also your lymph system, which is the superhighway in cancer, what is the lymph system? Well, your arteries and your veins are basically like the incoming plumbing in your house. It's what brings the water in. So you can get water and fresh water and you have something to drink. What are your lymph nodes? your lymph nodes are the sewer lines in your body. It carries all the junk out, all the dead cells, all of the waste material. But they are connected to everything. That's why once you get cancer in your lymph nodes, that's the superhighway, and it's a death sentence the majority of the time. This is why, 2 reasons. Cancer now not only has, because every organ is separated in a sense from the next organ, and it's made out of a different tissue type. So in order for cancer to get kidney cancer or pancreatic cancer or 1 second, my dog tap dancing on the floor is interrupting this video, so give me 1 second. So as I was saying, your organs, all of them are made of a different tissue type. You got striated muscle, you got smooth muscle, you got coarse muscle. Your heart is made out of different tissue. Your kidneys, pancreas, your muscles, your eyes, your brain, all made out of different tissue types. The reason why it's hard for cancer to just jump over to the next organ is because it has to learn that cell's DNA. It mutates and infects, and then after it mutates and infects, it uses that cell's mechanics to start reproducing itself. And it mutates the DNA, and it starts to clone itself. Cancer cells are clones. And so that's why it can't just jump from one organ to the next unless it has a connecting highway, i.e. your lymph system. And remember, I'm not a doctor. So for me to know this much about cancer is really, really sad. But I'm going to tell you some pretty surprising stuff, which makes me wonder why isn't it cured yet? I don't understand it. So, as your lymph system gets infected, cancer can travel all throughout the body now. It can connect to every organ that you have. You don't really see cancer in the veins and the arteries so much as you do the organs. What happens is cancer is just a mass of cells that continues to multiply until it presses against critical systems, like I showed you here within the cell. And what it does, it creates blockages to where, fluids can't flow in and out, nutrients can't flow in and out, waste cannot flow in and out of that organ. And it begins to kill that organ, whichever one's infected. And it's literally just a mass of cells growing out of control that have hit the delete button on how to die. They don't die. Cancer cells are immortal. They live forever until they kill the host. So here's the next thing that really blows my mind about cancer. And what I mean blows my mind is, out of all the smartsy, artsy doctors out there, and no insults to those out there that are doing the research and the work, okay, and aren't part of the corporate piggy bank that would like to see this industry continue because of money. In every strand of DNA, you have something called a double helix, okay? And this double helix looks like that, okay? This is a double helix. At the end of your double helix, you have something called telomeres. Now, okay, and it protects your chromosomes. Chromosomes are shaped like, basically just like an X, okay? They look like chromosomes. Chromosomes are basically like a SD card that's loaded up into your cell, gives it directions, tells it this is what your program is, this is what you're supposed to do. And on the end of the chromosomes, as I just demonstrated, are telomeres. These telomeres, every time a cell divides in a healthy cell, the telomere becomes thinner and thinner and thinner, like the enamel on your teeth if you eat a lot of sugar. It becomes thinner and thinner and thinner and thinner until eventually the telomere is completely worn away. And then when the cell divides the last time, when the telomeres are completely knocked off and worn away, the cell dies. It's like a natural cycle. Some cells divide 50 times, some divide 100 times, but they have a cell cycle where they have a certain age and they're supposed to die after so many divisions. Well, in cancer, these telomeres at the end of the chromosomes and each cell have become calcified, like hardened, and they don't thin out. Get where I'm going here? Whenever these telomeres have become hardened because of the mutation in the DNA, this chromosome is present here in the strand of DNA. And then you've got your, you do your mapping. It looks like a lattice. I haven't been to medical school, so that is a strand of DNA. That's in the strand of DNA. You have your chromosomes inside your DNA. These strands of DNA are present inside every cell. They tell the cell how to act, what to do, what its function is, what it's supposed to reproduce. It tells you, okay, your heart muscle, you reproduce in the heart muscle, your kidney tissue, your lung tissue, whatever. Your pancreatic tissue, you are to reproduce 50 times. After that, in the 50th time, you're to die. Okay? Well, the telomeres become hardened and calcified. That cell no longer dies. And then it reproduces another cell that no longer dies. And then another one, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048. Okay? 4096. Guys, get where I'm going? It starts to explode exponentially. That's why cancer grows slowly and then fast. Why is it? Now, and there's a way to do this. Every single cell has a thumbprint. That's why they can tell the difference between healthy cells and unhealthy cells, or striated muscle, or smooth muscle, or brain tissue, or liver tissue. Every cell has a thumbprint. Some of the differences are visible to the naked eye, but if you had a singular cell under a microscope, you can tell the difference because the DNA has a thumbprint that identifies that cell. And therefore, if you have a healthy cell with healthy DNA, and you have an unhealthy cell from the same organ, where it is now a cancer cell, you can identify the mutation in that cell. Okay, it's in the double helix, it's in the coding, and that mutation directly affects those telomeres. The telomeres causing them to become hardened and calcified, so when it dies, they don't thin out. The telomeres are essential. Telomeres. Just speak it into your Google search. Okay? And that's not where I learned this from. I learned this from 5 years of going to the doctor and piecing this stuff together and doing my own research. The telomeres become hardened and they don't thin out. And so these cells do not die. Why is it? And I know people would think, okay, so if we developed a cure, a vaccine, or a treatment or therapy that caused the telomeres that targeted specifically the material, the substance that telomeres are made out of, because they are made out of something different than the tissue that they are attached to cause that to thin out. People would be like, well, then all of the telomeres on every cell in your body would thin out and possibly compromise the good cells and the bad cells and kill them all. That is true. How do you avoid that? Well, obviously, the cells that have the, I call calcified or the hardened telomeres are mutated, i.e., their DNA thumbprint is different. So, engineer a serum, a vaccine, a cure, a therapy, a treatment, whatever label you want to put on it, that targets the DNA of that cell that has got the hardened, calcified telomeres, that cell that has become immortal, and either cause those cells to dissolve their telomeres quickly and immediately, which I think is probably the fastest way, because genetic and DNA coding, which is stem cell therapy, when you're trying to teach cells how to grow healthy again, much longer process, much harder process. Why don't we just rip the telomeres off the end of the cancer cells, cause them to dissolve, but develop a serum that leaves the healthy telomeres on the other cells? Because obviously those telomeres are, and I know I'm saying that word a bunch, guys, but it's necessary. Telomere. I get it. See, I was already getting tongue-tied. It's obviously made differently, so you could engineer on the biochemical level the substance you would introduce into the body that would target those telomeres on those cancerous cells to either cause them to dissolve slowly, so the cancer cells all die off slowly, because I think a rapid death of a whole bunch of cells in the body would probably send somebody into shock, but would cause them to slowly dissolve and start to die, which i.e. would kill the cancerous cells and thus cure the patient and end the cancer that is in the body. I have this information floating around in my head. You will find a lot of what I've talked about is factual. It's just the pathway of getting there. I don't know that. I'm not a chemist. I'm not a biochemist. I'm not a doctor. I'm not any of those things. But I do have an outside perspective. And sometimes that's what you need, just basically a basic fresh look at why aren't we doing this? I have a whole lot of useless or useful information floating around in my head, guys, and not just about cancer, about all kinds of things. Maybe you would, or maybe you wouldn't be amazed. But you can leave in the comments questions for me. Pick a subject, any subject. Ask me a question about it. I won't even do any research. I bet you I know something about it, and I'm not saying it from a cocky, prideful standpoint. It's just I got a lot of free time on my hand when it's, after 10 o'clock till about 3 a.m. I got 5 hours of insomnia I get to enjoy, and I do a lot of reading and a lot of research, just because my mind is constantly active, and if I don't feed it, it will be angry at me and keep me awake worse than it already does. So what do you think about that? Engineer a serum, whatever you want to call it, a vaccine, a substance that targets the telomeres of those cancerous cells, which you have identified through their DNA, like a thumbprint, so only those cells are targeted, that causes the telomeres to dissolve off of the end of their chromosomes, thus causing the cell to die, like it should, because that's all cancer cells are. A mass of cells that are immortal, that have an increased metabolism, that are dividing out of control and creating blockages in the body, thus starving either the waste outflow or the nutrient inflow and destroying that organ or those sections of the body. So, before I get this video too much longer, this is THC. You've gotten your dose for the day. Please leave a comment, guys. Talk to you later.